Absolute value graphs. There's a lot more possibilities with absolute values depending on where the absolute value appears. So what if it's just absolute value of the original function? So it's just simply y equals the absolute value of function x. This will end up having symmetry in the x-axis. So what we do, we reflect that bit of the function where function x is less than 0, we reflect it in the x-axis. Let's have a look. There's my original graph, y equals function x. If I want to draw y equals the absolute value of function x, the bit underneath now disappears because y can't be negative. So we're saying y is the absolute value. But what was below reflects above. Because the answer originally was saying -2. But we're saying y is the absolute value of that. So it now becomes positive 2. And any negative number now becomes positive. So whatever's below disappears, bang, gets reflected above. So that's y equals the absolute value of function x. Function absolute value x. Now what this means is we're only substituting in positive numbers. So when we substitute in x equals -2, we're going to get the same answer as if we substituted in positive 2. So this one's going to have symmetry in the y-axis. Okay. So again, we're going to have a reflection. So this time where x is greater than 0, that's going to reflect. Well, let's have a look at random curve. There's y equals function x. We're saying function absolute value x. So we cannot substitute in negative numbers. Goodbye. All that left-hand side's disappeared. And what's on the right-hand side? Whoop, gets reflected on the left. Because now, when we substitute in, and I'm using 2 as the example, but when I substitute in -2, it'll become absolute value of -2, so it'll get the same answer as when I substitute in 2. Everything on the left, reflected on the right. Okay. Absolute value of y is equal to function x. This also has symmetry in the x-axis, but this time we don't flip the below because we can't get well, let's do it. We reflect the part where the function x is positive. So in other words, where it is above the axis gets reflected below. Let's put it in. We're saying absolute value of y is equal to function x. So function x can't equal a negative number. No, we can't get a negative y. So anywhere where there was a negative y and the original disappears, but because it's absolute value y, it reflects. So we now have plus or minus the y value. So we get that symmetry in the x-axis for that one. How about absolute value of y is equal to function absolute value x? Okay. It's got symmetry in both the x and the y axes because we're absoluting both the x and the y. Okay. Reflect. It's basically the first quadrant gets reflected into all 4. Because we can only use positive numbers. We're absoluting x and we're absoluting y. So we can't have negative x's, we can't have negative y's. It's the first quadrant. Whatever is in the first quadrant gets reflected into all 4. So here's random curve. First quadrant. Whee! We reflect it into all 4. So it gets reflected below and across, or whichever way you want to do it. You could have gone across, then below. Y equals the absolute value of function absolute value x. So now y can only be exactly. But another way of thinking about this is, look, back here we did y equals function absolute value of x. We know what that looks like. And then the one before we said, oh, we know how to do an absolute value of a function. So you could think of it in 2 stages. First of all, I'm going to draw a function absolute value x, and then I'm going to say, oh, the absolute value of that curve. So we'll end up with symmetry in the y and reflection in the x. So here we go. Random curve. There's function x. Now, that's what we got for function absolute value x. But we're now saying the absolute value of that, what did we do for that? We said, well, whatever is below is reflected above. And we get that graph. Get some really cool graphs with absolute values. All right. Absolute value of y is equal to the absolute value of function x. Well, we know how to do absolute value of y as function x. And we also know how to do y equals the absolute value of function. Must be some sort of combination of these two. So this will have symmetry in the x-axis, reflection in the x-axis. And there's our basic description of what's going to happen. We're going to reflect the part of function x where it's less than 0. That's going to get reflected in the x-axis. And then we're going to reflect that result back. Huh? Okay. There's function x. That is what we got when we drew y equals the absolute value of function x. Whatever is below, reflected above. But we're now going to say the absolute value, because now we have plus or minus. Right? So I'll go back. Remember, when we said absolute value of y, we said y can be negative, so we get rid of it all. But in this case, nothing's negative anyway, so there's nothing to get rid of. But then we said, okay, go reflect it. And so we end up with this lovely twisting shape. There we go. So, all right.